So this assignment is related to electromagnetic effects. A current carrying wire is placed between the two poles of a magnet, as you can see here. The magnetic flux density in the region between the poles is 0.070 Tesla. The current is there, the length of a wire which is placed in a magnetic field, magnet is also there. Which of the following give us the magnitude of the force on the wire? So, and its direction. So first, how you can work out the direction? To work out it, because to work out the direction, what we will use left hand rule, Fleming's left hand rule. So according to Fleming's left hand rule, the index finger, the first finger, represent the magnetic field. The second finger represent the direction of the current, and the thumb will represent the direction of force. So index finger or the first finger represent the magnetic field south, the south pole. The second finger that will represent the direction of the conventional current, and the thumb automatically when representing the direction of the force. So when you apply the rule, your index finger, the first finger should point towards south. That is your index finger. So first finger is pointing towards south. Second is representing the direction of the current. So index finger is pointing towards south, that is downward, and second is representing the direction of the current. As you can see, this is the direction of the current. So when I apply the rule, my second finger should point in this index finger and then second finger, and where my thumb is pointing automatically, that will give us the direction of the force. So what will be the direction of the force here? When you work out, you will find it is coming out of the plane. So the force will be out. So force is outward, and you will apply a rule. So you use your left hand. So force is outward. So it means option A and B can be an answer. Either C can be an answer or D. But now which length we should take? We should take a length of a wire which is perpendicular. So the length of a wire, like the total length of a wire is 6.5 centimeter. But which part of a wire, which length of a wire, which is perpendicular to magnetic field? So when we, like this is the magnetic field, which is from north to south. So this is 6.5 and the horizontal length is 5. This is given 5 centimeter. So what length we will take means we will take a length 5 centimeter in our calculation, because we always take a length which is perpendicular to the magnetic field. So 6.5 is the total length of a wire, but that's not perpendicular, because if this is 6.5, the magnetic field is not perpendicular to that 90 degrees. We want a length which is 90 degrees to the magnetic field. So in that case, this 5 centimeter will be perpendicular, or 5 centimeter we convert into meter, which is 0.05. And how to get the strength of a magnetic field in Newton? So we have the formula F is equals to BIL, where B is the strength of a magnetic field, 0.0 Tesla is there. I is the current which is passing through, that's 1.5, and 0.05 is the length which is perpendicular to the magnetic field, and the direction will be out of the page. So with reference to this, option C will be the right answer. Is it clear? The next question, a current carrying conductor is placed perpendicular or 90 degrees to the magnetic field, and the magnetic flux density is 0.05 Tesla. The length of a wire is 10 centimeter. Don't forget to convert into meter. So that is 0.1. And the force is 2 exponent minus 3 or 0.002 Newton. So we want a current. We have the formula F is equals to BIL. Or you can also use BIL sine theta. And because in the question they mentioned it is perpendicular, so theta is always 90 when it is perpendicular and sine 90 is maximum or 1. So F is equals to BIL, where F is a force which is 2 into 10 power minus 3. The strength of a magnetic field is 0.05. I is the current which is passing through this. We are finding L is the length of a wire, 0.1, and sine theta or sine 90, which is 1. So it will be 2 into 10 power minus 3 divided by 0.05 into 0.1. That will give us the value for current, which is 4 exponent minus 0.4 is there, which is 4 exponent minus 1. So D will be the right answer. So same formula we use. Even I can directly write F is equals to BIL as the wire is perpendicular and sine 90 is 1. The next one, the particle of mass M and charge Q move in a circle perpendicular to magnetic field. So what happened? The magnetic force is causing a rotation. So means we can say the magnetic field is equals to centripetal force. The graph shows the relation between radius of orbit r and the velocity, the gradient of the graph. So how to work out what is the gradient of this graph? So we have the formula. Look, the magnetic force is equals to centripetal force. Centripetal force is given by a formula mv square over r. Magnetic force is given by magnetic force on the charge qvb, which v is where v is the velocity. So this v will cancel with square. So we are left with m v over r is equals to qb. And we are plotting a graph. We have r on y-axis and v on x-axis. So if this r is divided, other side multiplied, so mv is equals to qbr. Or I can say mv over qb is equals to r. Or I can say r is equals to m qb into v, like I just rearrange. Now I'll compare with the equation of straight line. Then on y-axis if I have r, and on x-axis if I have v. So on our y-axis we have r, x-axis we have what is the gradient? The gradient will be equal to m divided by qb. So the gradient is equals to m divided by qb. So with reference to that, A will be the right answer. Is it clear, this one? Then in question 4, a current carrying conductor is placed into a magnetic field. If the magnetic force experienced by the wire balance the weight, the wire will float. The direction of a magnetic field is from west to east. For the wire to float, it must be, first thing, whenever we are placing a wire, the wire cannot be because if the wire is placed parallel to magnetic field, it won't experience any force. So option A and B are totally wrong. The wire must be perpendicular. And what is happening? Like we have north is there, south is there, east is there, and west. And the direction of a magnetic field is from west to east. So this is the direction of a magnetic field. That is from west to east. So which direction the current and the weight of this wire is acting downward. So the wire must be perpendicular. So which direction the current should move or flow so that it can balance with the weight. So when we apply, the current is there from north to south. Like this is the direction of a magnetic field. If we take a current is from north to south, if current is from north to south, first finger represent a magnetic field which is pointing towards. Because weight is like when we draw a compass, the weight is the force which is directed towards the center. So weight is the force of a gravity which is in. What we want the force to be out to balance with the weight. So if weight is in, we want the magnetic force out of the plane. So if the magnetic field is from west to east, the index finger is pointing towards east, and the direction of the current is from north to south, like downward. So this is the direction of a current, this is the direction of field. So where the thumb is pointing, your thumb will point outward. So if your thumb is pointing outward, that will balance with the weight, which is the inward force. So this will cause the wire to float.